Hey class, sorry I can't be there in person, but I hope that if you need help with some review examples, this video finds you well. All right, so I'm just gonna walk through a few examples from each section in Unit 4. So hopefully, you can watch what you need here and then skip what you don't, and it'll help you prepare for the test. First, we added and subtracted with polynomials. And I'm just doing a subtracting one. In both adding and subtracting, you want to combine like terms. But when we subtract, we have to remember that it's like we have a -1 in front of the second parenthesis, so you do have to distribute that -1 into the second set of parentheses. The first parenthesis has a +1 out front, so that one stays the same. But then you subtract, so -1 times 4x cubed would be -4x cubed. -1 times 6x is -6x, and -1 times -8 is +8. And then combine like terms from highest exponent to lowest. So x cubed minus 4x cubed would be -3x cubed. And then we just have one x squared term, so just -2x squared, so minus 2x squared. Then we have a plus 5x and a minus 6x. 5 minus 6 is -1x. And then -7 plus 8 would be +1. So just combining like terms. And we add the coefficients when we combine like terms and keep the exponent part the same. Okay, identifying. Is it a polynomial? Yes, no, why, and then what's its name? So this one is not a polynomial because it has a negative as an exponent, and polynomials have to have real number coefficients and whole number exponents. So no negatives, no fractions, no variables, etc. So it's not a polynomial. -5x squared plus 3 minus 12x cubed is a polynomial because it's real number coefficients and whole number exponents. In standard form, it'd be f of x equals, or y equals, you'd put the -12x to the third first because that's the highest degree, then minus 5x squared, then plus 3, which means it's a degree of 3, which is called a cubic. It has 3 terms, so it's a trinomial. And the leading coefficient would be -12. So we had a lot of constant, linear, quadratic, cubic, quartic, and then monomial, binomial, trinomial, polynomial. So we have a lot of things to remember in that section. So this one is also a polynomial. It is actually already in standard form. The highest exponent term is out front. Its leading coefficient is -2. It wants a sketch, so it is a odd function because it has a exponent of 3, and the a value, the leading coefficient, is negative. So it's cubic, so it looks something like this, which means the end behavior is as x goes to the positive side, the function, the y, would go to the negative. You'd go down. As you go to the negative side on the x-axis, so the x-axis positive, x-axis negative, the y, the function, would go up to the positive infinity. You'd be up here. So on the right, you go down, it would go down, and on the left, it would go up. Remember, like y equals -x is the very basic odd function. So negative slope, it has a negative slope. It decreases from left to right if it's odd and negative. Whereas this one is already in standard form, but it is an even function, even, and a is +5, which means it would have positive even, so it'd like open up. Now it's a degree of 6, and so it might have a few more turns in there, you know. It's not going to be a perfect parabola. But if you look at the xy axis, as you go to the right on the x or the left, as you go to the right, so to the positive, the function would go up, positive. As you go to the left, the function would go down positive again, up again. So on both the right and left, the function goes up because it's even. Evens always either go up and up or down and down, depending on if it's positive or negative out front. So graphing this. So if I wanted to graph, I made a table. I always chose -2, -1, 0, 1, 2. And I did that because I wanted to know what happens in the middle of the function. And then we used end behavior. So this was an even function with a leading coefficient of 1. So I know it's going to open up essentially. So once I figure out what happens in the middle, then I graph it and I use my end behavior to open it up. Make sure that it continues to open up. Now you can use synthetic substitution if you would like to plug these in. So remember synthetic substitution, you take the coefficient. So I'm going to plug in -2 first. It would be 1, 2, -5, and 1. Oh, I actually am missing an x squared. So it would be 1, 2, 0, -5, 1. And then drop down the first one, then multiply -2 times 1, then add, multiply, add, multiply, add, multiply, add. You get 11, so -2, 11. So you can use synthetic substitution, or you can use your calculator as well. It'd be a well, we already did -2, so let's do -1. Use the caret to the 4th power. You have to get out of the exponent. Plus 2 times -1 to the 3rd power. Minus 5 times -1 plus 1. Now you won't have a graphing calculator, so you will have to enter this into a regular calculator. But if you plug in 0, you're going to get out 1. If you plug in +1, get -1, and then plugging in 2. Be 23. And then graphing that. So -2, 11 would be up here, -1, 5, 0, 1, 1, -1, and then 2, 23 would be way off our graph. So it's going to look something like this. And it's going to continue infinitely to increase. So I can draw my arrows there because I know the end behavior is positive. It'll continue to go up. So that's how we graph all the polynomials. Choose -2 to 2, graph the middle, make sure the end behavior matches what it's supposed to look like. Write a polynomial function with the following end behavior. So this is going to say something like this. When x goes to the left, the function goes down. And when x goes to the right, so when you go to the right on the graph, the function here, the y value, goes up. So I want something that when you go to the left, the function goes down. And when you go to the, oops, I wrote that backwards. When you go to the left, the function goes down. And when you go to the right, the function goes up. So it could be something as simple as a straight line, like y equals x. You could make it a little bit more complicated and go down over here and then up over here, do a little turn in there. So y equals x cubed. But if it has this end behavior, it has to be an odd function and it has positive slope. So your a value would have to be positive. So you can do any polynomial that has an odd degree, and a positive leading coefficient would be a correct answer for this particular question. How about this end behavior? So this says as x goes to -infinity. So as you go to the left, and then the function goes to infinity, the function goes up. Or as x goes to infinity, so as x, you go to the right, then f of x goes to infinity, the function goes up. So basically, it says on the left side it goes up, and on the right side it goes up. On the left and right, it both goes up. For some reason, I keep mixing that up. But so if it both goes up, that's going to be something like this. So you can have any even degree function polynomial this time. And if it opens up, you want a to be positive value again. So you could have y equals x squared, y equals 3x to the sixth. It could have a monomial term, one term. You could have a trinomial as an example, but it has to have an even degree, and your a value would have to be positive to give me a correct answer for a polynomial function that has that end behavior. Okay, multiplying. Now I use the box to help me keep this type of problem organized. 2 by 3. And I did x minus 4, and then times 2x squared plus 3x, so 3x, and then 5. But really it's the distributive property. Multiply the x times 2x squared, so x times 2x squared would be 2x cubed. X times 3x would be 3x squared. X times 5 would be 5x. And then distribute the negative 4. Negative 4 times 2x squared would be negative 8x squared. Negative 4 times 3x would be negative 12x. And then negative 4 times 5 would be negative 20. And then go through and combine your like terms. If you use the box method, the like terms will be in the diagonals. So you'll see you have a 2x cubed, and then you have a negative 8x squared plus 3x squared is negative 5x squared. So you're adding at this point. Negative 12x plus 5 is negative 7x, and then minus 20. That would be the answer. Okay, there was a formula that you can use for multiplying out a cubic. I gave you that formula at the bottom of your notes, but what I recommend is just, instead of memorizing the formula, just multiplying it out. 3x minus 2 times 3x minus 2 times 3x minus 2. So you do these first two. So FOIL this, or distribute it. So 3x times 3x is 9x squared. 3x times negative 2 is negative 6x. Negative 2 times 3x is negative 6x. Negative 2 times negative 2 is 4. Combine like terms. So 9x squared. These two are together being negative 12x plus 4. So that's multiplying the first two. Then take that product times 3x minus 2. So I'm going to use the box again just to keep my work more organized, or you can distribute. So take the 9x times both. So 9x squared times 3x is 27x cubed. 9x squared times negative 2 is negative 18x squared. Then distribute the negative 12 to both. Negative 12x times 3x would be 12, 24, 36, negative 36x. And then negative 12x times negative 2 would be 24x. And then distribute the 4 to both. 4 times 3x is 12x. 4 times negative 2 is negative 8. And then same thing as before. Combine your like terms. I wonder if I missed x squared here. Yes, I did. This was supposed to be an x squared. So 27x cubed, negative 18, and negative 36 would be negative 54x squared. 24 and 12 would be 36x, and then minus 8 be our answer. So remember these 7x minus 3 and 7x plus 3, this is conjugates. So this would be 49x squared minus 9 if you multiplied it back out. So it's the difference of perfect squares. A squared minus b squared is a plus b and a minus b. And so if you are given a minus b times a plus b, square the first one, square the last one. Well, negative 3 times 3, so you multiply that out. It only works when they're conjugate, so the same thing except for one's plus and one's minus. If you are unsure, then just multiply it out and double check. You're going to get 49x squared, you're going to get negative 21x, positive 21x, and then negative 9. You'll see that the middle terms cancel. So you get 49x squared minus 9. Okay, factoring. 27x cubed plus 8. Remember when you factor, I always look for greatest common factor. I can't take anything out there. Then we have a cube. So this one we're going to need a cubed plus b cubed formula. So it goes a plus b, a squared, minus ab plus b squared is the formula. 27x cubed, the cubed root of 27 is 3x, so that's going to be, 3x is going to be our a, because 3x cubed is 27. And then 8, the cubed root of 8 is 2, so 2 cubed gives me 8, so b will be 2. Plugging that in, it'd be 3x plus 2 for a plus b, and then 3x squared, a squared, minus a times b, so minus 3x times 2 plus 2 squared. So just rewriting that, then 3x plus 2, and then 3x squared would be 9x squared, 3x times 2 would be minus 6x, and 2 squared would be 4. And then that would be factored. Now, I'm not asking to solve at this point because there's no equal sign for one. But if we were to solve this, we would have to use the quadratic formula for this piece. Okay, factor here. Remember, I always look for greatest common factor, so this one I can take out a 7 this time. Dividing both by 7, I get x to the 4th minus 4. And then x to the 4th minus 4, these are perfect squares, a squared minus b squared, because a plus, so it would factor to a plus b and a minus b. Because x to the 4th is x squared times x squared, and 4, negative 4, is positive 2 times negative 2. So it factors down to that. This one is difference of perfect squares again. 64x to the 4th is 8x squared times 8x squared, and negative 1 is positive 1 times negative 1. And that's as far as it goes. If this would have been like a 9 here, you could have factored that one more time. But find all the solutions. So remember, this is a cubic, so I'm going to have 3 solutions. It is a polynomial of 4 terms, which means that I need to factor by grouping. This one's asking me to solve because I have an equal to 0 this time. So that's the difference between the factor ones and the solve ones. So I'm going to solve factor by grouping. So group, then take the greatest common factor out from the first group, which would be x squared, and be left, if I divide this by x squared and this by x squared, it'd be x minus 3 left there. And then I want to make the second parenthesis an x minus 3 as well. So I'm going to take out the negative 4 and divide both by negative 4. You're going to get x minus 3. And then you have 2 terms here, and they each have an x minus 3 in common. So I'm going to take the x minus 3 out front, which means I'm going to divide both terms by x minus 3. So what's left is going to be x squared minus 4 equals 0. Now technically x squared minus 4 does factor to x plus 2 and x minus 2, but I'm just wanting to solve now, so I don't have to factor all the way down. When you get to a quadratic, you can set the factors equal to 0 and solve. This one you would add 3 and I'd get x equals 3. Here I would add 4 and then I'd solve by square roots. So square root both sides, and then just remember that the square root of 4 is positive or negative 2. So I did get 3 answers there. Positive 3 and then positive or negative 2. So here are find all the solutions of this equation. So this time I'm looking for 4 answers because it's a quartic binomial. I'm going to start by taking out the greatest common factor, which would be a 2x. That's going to leave me with an x cubed plus 54 divided by 2 is 27. Now I have an x cubed and a 27, so that's an a cubed plus b cubed. So I have to use the formula for that, which is a plus b, a squared minus ab plus b squared, where a would just be x this time and b would be 3 because it's x cubed plus 3 cubed would equal x cubed plus 27. So I'm going to still have the 2x there, and then this will factor to first a plus b, so a plus b would be x plus 3, so I'm plugging it into this formula here. And then a squared would be x squared minus a times b, so x times 3 would be 3x, and then plus b squared would be 3 squared, which would be 9. Okay, then you're down to quadratics, so set each factor equal to 0 and solve. 2x equals 0, x plus 3 equals 0, or x squared minus 3x plus 9 equals 0. So for 2x equals 0, divide by 2, we get x equals 0. For x plus 3 equals 0, subtract 3, get x equals negative 3. For this one, unfortunately, you have to use the quadratic formula. So a is 1, b is negative 3, and c is 9. And it's x equals negative b plus and minus square root b squared minus 4ac all over 2a. So you get x equals negative b, so negative 3, plus and minus the square root, b squared would be negative 3 squared, minus 4 times 1 times 9, all over 2 times 1. Okay, so negative 3 would be just positive 3, plus or minus the square root would be 9 minus 36, 4 times 9, negative 4 times 9, over 2. So it'd be 3 plus or minus the square root of negative 27 over 2. The square root of negative 27 is the same thing as the square root of negative 9 times the square root of 3, so it'd be 3i square roots of 3. You could also break it down, 9 times 3, 3 times 3, bring out a 3. And it's imaginary because 27 is negative. So, final answer, 3 plus or minus 3i square roots of 3 all over 2. This does not simplify more since 3, 3, and 2 are not divisible by anything that's the same. So we have 4 answers then. 0, negative 3, and then 3 plus 3i square roots of 3 over 2, and 3 minus 3i square roots of 3 over 2. So 2 real solutions there, and 2 imaginary solutions for that one. Okay, find all the solutions to this equation. Before we can solve, we're using the zero product property, so you do have to have it equal to 0. So I'm going to subtract the 3x cubed. So it's going to be negative 3x cubed plus 6x squared plus 21x. Then I'm going to divide everything here by the negative 3 and just get rid of that first. So 0 equals, then x cubed minus 2x squared minus 7x. Okay, then I can factor out an x. So x squared minus 2x minus 7. And then factor the x squared minus 2x minus 7. Trinomial, use the box or guess and check. So x squared, negative 7. So 1 times negative 7 is negative 7. It has to multiply to negative 7, add up to negative 2. Would be... Oh, it does not factor. So unfortunately, then you would have to use the quadratic formula again. Or we could do it with completing the square let's do that way real quick. So x squared minus 2x minus 7 equals 0. So we get x squared minus 2x plus blank equals 7 plus blank. First step is to add the constant to the other side. And then we take the b divided by 2 and square it. So you get negative 1 squared is 1. Then we factor it, and it would factor to x minus 1 squared equals 8. Then you square root both sides. You get x minus 1 equals square root of 8 would be 2 times 4 is 2 times 2, so it would be plus or minus 2 square roots of 2. And then you add 1 to both sides, and you get x equals 1 plus or minus 2 square roots of 2. So if you did the quadratic formula, you get the same answer. And then my third answer would be this x equals 0 right there too, because I'd set both equal to 0. So I get one answer from x equals 0 there, and then my other two answers from solving this one, which I did with completing the square this time. Quadratic formula would work as well since it doesn't factor. Synthetic substitution is when you take the coefficients in order, so you plug in the 2 and then you do 2, negative 3, 1, negative 5. Just make sure that you have a spot for every coefficient. So if I was missing, say this term was missing, I would add a 0 in the x squared spot. Or if the 5 was missing, I'd add a 0 at the end. So you need a placeholder for every spot from highest exponent down to the constant. So 2, negative 3, 1, negative 5. Drop it down, drop mama. Then multiply, 2 times 2 is 4. Then add, negative 3 plus 4 is 1. Multiply, 2 times 1 is 2. Add, 1 plus 2 is 3. Multiply, 2 times 3 is 6. Add, negative 5 plus 6 is 1. The final, for synthetic substitution, the final one is your answer. So that means like the function evaluated at 2 equals 1. Now synthetic division is similar. So we use synthetic substitution. First you solve this one. So you'd say x is going to equal negative 2. So I'm going to plug in negative 2 as synthetically. So write down the coefficients. So 2, 6. I'm actually missing the x term, so you have to add a 0 for x and then negative 9. Drop it down. First one comes down, then multiply. Negative 2 times 2 is negative 4. Add, 6 plus negative 4 is 2. Negative 2 times 2 is negative 4 again. Add, you're going to get negative 4. Negative 2 times negative 4 is 8. Negative 9 plus 8 is negative 1. So this one has a remainder. It was a cubic, and we divided it by an x, though, so it goes down by 1 degree. So this was cubed, so this one will be an x squared, this will be an x, the 4 will be my constant, and the 1 is the remainder. And so it'll be 2x squared plus 2x minus 4, and then you write the remainder. It's negative, so I would write it as minus 1 over x plus 2, what you divide it by. You could write it as plus and then negative 1 over x plus 2 as well. Or just, instead of writing plus, just write minus and then the 1 like that. But if you have a remainder, it always goes back over what you divided by on the end. And if there was no remainder, then that means that x plus 2 was a factor of that polynomial. So it like divided into there evenly. And long division we skipped this year, so we did not do any long division problems. And so that is it. We are done reviewing. I hope this was helpful if you needed it and you used it. Thanks for watching.